Imagine the tallest mountain you've ever seen, Everest, the Rockies. Now multiply that by 3. Our solar system's true giant isn't on Earth, but on Mars. Olympus Mons, the largest volcano and tallest mountain anywhere we know. Unlike Earth's sharp peaks, Olympus Mons is a massive, gently sloping, shield volcano. If you stood at its base, you wouldn't even see the summit. The slope is so gradual, the horizon hides it. Everest is a dangerous, icy climb. Olympus Mons, nearly 3 times taller, rising 25 kilometers, 16 miles, above the Martian plains. Its base is so wide, it could cover all of Arizona. This isn't just a mountain, it's a planetary landmark, reshaping how we think about geology. When you look at Mars in the night sky, remember, it hides wonders like Olympus Mons, a silent giant billions of years old. Exploring it, even from afar, helps us understand Mars, and our own place in the universe. Olympus Mons inspires us to keep exploring, to dream of the day humans might stand on its summit. The adventure is just beginning. Olympus Mons is so massive, it's hard to comprehend. Mount Everest stands at 8.8 kilometers. Olympus Mons towers at 25 kilometers, almost 3 Everests stacked. Its base, 600 kilometers across, about the distance from Paris to Amsterdam. Imagine a mountain covering most of France or all of Arizona. The slope is gentle, only about 5 degrees, so from the base the summit is hidden by the horizon. Walking up Olympus Mons would feel like a never-ending, slightly tilted plane. Its summit sometimes rises above Mars's global dust storms, peeking into clear, thin air, while the world below is shrouded in red haze. Olympus Mons is so big, it creates its own environment, a world within a world. Its sheer scale is unlike anything on Earth. The Martian sky, the landscape, even the weather are shaped by this colossal volcano. Understanding Olympus Mons helps us appreciate the extremes of our solar system. It's a reminder, the universe is far stranger and grander than we imagine. And Mars is just the beginning. How did Olympus Mons become so enormous? It's a shield volcano, built not by violent eruptions, but by slow, steady flows of fluid lava, like honey spreading on a table, but on a planetary scale. For billions of years, a hot spot in Mars's mantle fed lava to the same spot, layer by layer. Mars's lower gravity, just 38% of Earth's, let the mountain grow taller and wider than anything possible here. The lava was so fluid, it traveled for hundreds of kilometers before cooling, creating those gentle slopes. High-resolution images show ancient lava flows, frozen rivers of rock, some stretching for hundreds of kilometers. Olympus Mons is a monument to Mars's fiery, dynamic past, a world that once boiled with volcanic activity. Its size is a direct result of Mars's unique properties, low gravity, a stationary hotspot, and eons of patient construction. Today, it stands as a silent record of a planet transformed. Studying it reveals the secrets of Mars' ancient volcanic heart. Olympus Mons is proof the universe builds on a scale we can barely imagine, and Mars' story is still being written. Olympus Mons owes its size to something Mars lacks: plate tectonics. On Earth, moving plates shift volcanoes off their hotspots, limiting their growth, like building a sandcastle on a moving walkway. Mars's crust is a single solid shell. The hotspot under Olympus Mons stayed put for billions of years. Lava kept piling up in one place, letting the volcano grow to record-breaking size. No moving plates meant no chains of volcanoes, just a few giants clustered in the Tharsis region. Olympus Mons is the biggest, but it has massive neighbors. Mars's static surface preserves these features for eons, unlike Earth's ever-changing crust. The lack of tectonics shaped the entire Martian landscape. Olympus Mons is a monument to stillness, a record of a planet that never moved on. It's a fundamental difference that makes Mars look so alien, and it's why Olympus Mons stands alone as the solar system's greatest volcano. Imagine standing on the summit of Olympus Mons. You'd need a special spacesuit. The air is less than 1% of Earth's, and the sun's radiation is intense. The sky would be a dark, purplish black, even at noon, with stars visible overhead. Instead of a dramatic peak, you'd see a vast, high plateau, the slopes gently curving away, the summit hidden by the planet's curvature. The temperature? Frigid, well below -100 degrees. Wispy clouds of water ice might drift by, and dust storms could sweep up the slopes, coating everything in red. The summit is a complex caldera, a series of overlapping craters, not a single peak. Cliffs, terraces, and flat floors tell the story of the volcano's final eruptions. Exploring the summit would feel like walking through the ruins of a geological cathedral. It's beautiful, harsh, and utterly alien. Olympus Mons is a summit like no other in the solar system. The summit of Olympus Mons is a destination, a caldera complex 85 kilometers wide. 6 overlapping calderas formed by collapses after massive eruptions create a landscape of cliffs and scarps several kilometers high. Walking here, you'd cross smooth plains, climb rugged cliffs, and see layers of Martian history exposed in stone. High-resolution images reveal fractures, ridges, and dust-covered plains, evidence of recent volcanic activity, perhaps just a few million years old. Each caldera has its own story, its own character. Exploring them would take weeks, maybe months, even with rovers and climbing gear. For geologists, it's a paradise, a history book written in rock. By mapping and sampling these features, we could piece together the final chapters of Olympus Mons' volcanic saga. The summit's crown is a monument to Mars's restless past, and it's waiting for explorers to unlock its secrets. No human or rover has set foot on Olympus Mons, but our orbiters have mapped it in stunning detail. From Mariner 9's first images in 1971 to today's Mars Reconnaissance Orbiter, we've used cameras, laser altimeters, and spectrometers to study every feature. We've measured its height, mapped its slopes, and traced ancient lava flows. High-resolution images reveal details as small as a coffee table. Landing there is a challenge. The summit's air is too thin for parachutes, so future missions will need new technology. Despite the obstacles, orbital data has built a detailed geological history of Olympus Mons and the Tharsis region. We've identified strange ridges and the massive aureole around its base, evidence of ancient landslides. Every image brings us closer to understanding this Martian wonder. Our robotic explorers are paving the way for future missions. One day, we'll see Olympus Mons up close. Mars's harsh environment makes survival tough, but Olympus Mons might offer a solution: lava tubes. These natural tunnels formed by flowing lava could be enormous on Mars, big enough to house entire cities. Lava tubes would shield astronauts from radiation, temperature swings, and micrometeoroids. Orbiters have spotted possible skylights, collapsed pits that could be entrances to these underground networks. Future missions might send robots to explore these caves, searching for safe havens. If stable, lava tubes could become prime real estate for the first Martian settlements. The summit's height also makes it perfect for an astronomical observatory, with clear views above the thin atmosphere. Olympus Mons could be both a home and a scientific outpost. Its geology and location offer endless opportunities for discovery. The volcano's future may be as important as its past. Olympus Mons is more than a mountain. It's a symbol of human curiosity and the spirit of exploration. Imagine being among the first to climb its endless slope, every step a leap into the unknown. The silence, the vastness, the view from the summit, standing on the highest point in the solar system. You'd carry the hopes of all who dreamed of reaching Mars. From the summit, Earth would be a tiny blue star, a reminder of home and how far we've come. The journey to Olympus Mons will be long and difficult, but it's in our nature to climb, to explore, to learn. One day we'll stand on its summit, not just because it's there, but because of what it teaches us about the universe and ourselves. So next time you see Mars in the night sky, imagine standing atop its mighty mountain. Olympus Mons calls to us, a silent giant, waiting for explorers to arrive. Our future is written in the stars, and Olympus Mons is part of that story.